Hey everybody, welcome to Lab 7, Charles's Law. We're going to be exploring the relationship between volume and temperature and the way that that works with, let's say, a gas that we cool down from a hot temperature to a lower temperature and observe a volume change. The thing about gas is that gas can change volume depending on what the temperature is, but something that does not change volume very much is water. So what we're using today is we're drawing a little bit of water into a flask in order to fill in that empty space created by the void of the gas. It's going to be held at a relatively constant pressure. So the thing that's going to change more than anything else is going to be specifically the volume, drawing in that water and giving us a measurement. So what we have to do first is we have to actually dry out our flasks to make sure that we're only working with air. So what we're going to do is we're going to start up this Bunsen burner. Nice strong Bunsen burner there. And then what we're going to do is take our flask and heat it up. I already heated it a little bit beforehand, but you can see a little bit of water vapor in there. And that's mostly caused by water that settles on the surface of anything that's cold, especially surfaces that are somewhat polar, like let's say glass in particular. So you only need to give it enough of a heat to get rid of a lot of that vapor. If you can't see vapor anymore, you're probably not going to be worrying too much about any more water. It's pretty small as far as the actual content goes anyways, but it's worth removing. So what we're going to do once we have our flask heated up is we're going to sit it down for a second, and we're going to go to our water bath, which we've heated beforehand, and we're going to place this flask in a clamp. So if it's too hot, you might actually burn a little bit of plastic onto that flask. It's not too big a deal. It's going to let it cool down a little bit, but for the most part, the flask will probably stay put that way anyways, so that's fine. A little bit of plastic won't hurt what we're doing today. So what we're going to start with is placing it into this water bath and making sure that it's seated with as much of that water contact as possible. Here's the reason why we're doing that. In particular, this water is going to be heating the gas inside of the flask. So we really want as much of that heat getting transferred to the gas as possible. Maximum contact is ideal, but if you get most of it underwater, then you're pretty good. So with that, you're going to also put in the stopper with a little piece of pipette, and that's going to prevent moisture from getting in, but also it's going to keep basically the water from entering the flask very quickly once you put it into the ice bath, which we've also set up ahead of time. Finally, what we're going to do is we're going to take this thermometer and we're going to place it inside of the water bath in order to get an idea of what temperature we're working with. Looks like we're running at about boiling, and once you get a boiling temperature in your flask, you should wait about 5 minutes to make sure that all of the air inside the flask acclimates to this boiling temperature. And once you begin, once you get to that temperature, those 5 minutes, you're going to record the temperature again just to make sure that you actually are recording the initial temperature as soon as the flask leaves the water and goes into the ice bath for that big temperature change. If you're mostly worried about messing up in the usual air that you'd be expecting, is going to be holding the flask for a long time in the air, moving from the hot water to the ice bath. But if you cover the tip with your finger, which you should anyways, just in order to make sure that you actually get a good seal under the water, that's going to be pretty avoidable for the most part. And as long as you take the actual careful amount of time to allow it to cool, you're going to see that water get drawn into the flask. An important thing to note when you put the flask underwater is that once you actually let the flask pull water in, it's very important that you don't allow bubbles to leave the tip of this. If you do see bubbles, it's a good sign that you're letting water in because it's not tilted quite right. You want to be only drawing water in caused by temperature change. So it's very important that you keep the tip of this downward and prevent any kind of bubbles from leaving the flask. Hey everybody, so welcome back. It's been boiling for about 5 minutes and we're going to take this off. Unfortunately, I think it was pretty hot because you can still smell the burning plastic. Before we actually move this, we're going to take the thermometer and we're going to check the thermometer and record the temperature. So right now, I have it screaming boiling hot and we're running at about exactly 101 degrees Celsius. You're gonna have to convert that to Kelvin eventually, but it's a valuable thing to just keep tabs on those temperatures as often as you can. So I'm gonna record that, then I'm gonna move this just in case I forget. So let's see. Lost my good marker. So it's gonna be 101 degrees Celsius, 101.0. I really keep those sig figs if you can. And then what you're gonna do is you're going to carefully remove the flask. You're going to put your finger on top of the flask as it cools, and you're going to dip it into the ice bath. So what's important is that you don't let bubbles come out of this, and you want to cool it evenly. So once you let your finger go, some of the water will begin to automatically flow in. What you're looking for is bubbles. So if you can find a clear spot, it's always good to know that you're not going to be losing any of that gas because of, let's say, just a leak somewhere. So from here, you're just gonna hold this for about 4 minutes and you're gonna let it acclimate. In the meantime, you're gonna take this thermometer, you're gonna carefully find the new temperature. So, alcohol thermometer is gonna lower, it's getting colder and colder, down to 10 degrees Celsius, down to I'll let it kind of acclimate there. Remember that you don't want to be doing anything that's going to be jiggling this and potentially knocking off the tip because that can cause a lot of problems. Specifically, it can make you have to do everything all over again. So keeping it steady is critical. And the temperature seems to be sitting at about 1 degrees Celsius. So I'm gonna do 1.0. And we're gonna call that. When it comes to any kind of ice water, you can be confident that you're not gonna change the temperature of the water too much because the ice is gonna stabilize that temperature. It's gonna stay put. You're not gonna really lose any of that water, or sorry, any of those degrees Celsius because the water is going to be instantly cooled back down by the ice. Well, hey there. So, welcome back. Basically, we're going to, at this point, take our finger and make sure that we keep all that liquid inside of the flask. So we're gonna cover up that hole again, making sure not to knock off the tip. And we're going to pull it back up. So you could hypothetically take the volume of this based on the reading on this flask, but it's pretty inaccurate. So what we're gonna do instead is we're going to actually take the flask and make sure that we also get all the water from the top out of there. So here, let's kind of jiggle this loose now that we have it upright. There we go. And take the flask over to the sink where we're going to measure out exactly how much of that liquid we took in. We have a graduated cylinder here instead. Much better way to measure this. There's going to be some transfer loss, that's to be expected. And just dump a little water in there. And we're gonna see how much we got. So, depending on how much water may or may not have gotten in accidentally, what we ended up with was about, 68 milliliters. I would say 68 exactly, maybe 68.1. We're gonna write that down on a results sheet. So, the volume of water after intake, that's gonna be 68.1 milliliters. Now we still have two important missing spots here. We have the initial volume of air in the flask, and we have the final volume of air after the intake. So those are the numbers that actually matter, V1 and V2. The way we're gonna get those is we're gonna first find the full volume of the flask. And now since the flask we had to have dry before is wet already, we're gonna go through figuring that out. So if you're gonna use the same flask, you don't really need to do this one twice, but you can, never hurts. In order to keep this straightforward, I'm just gonna do that part once. So you're gonna take your flask and you're going to grab the top, because that matters too. And we're gonna go fill it up over at the sink with a little bit of water. Now you have graduations on here, but they're not all the way to the top and for the full volume of the flasks. So what I'm gonna do is I'm actually gonna go back and get the graduated cylinder, and I'm going to find the volume of this once I fill it up entirely. So, try to fill it up as much as possible. It's important to also make sure that you compensate for the volume that's inside of this tube. It's a good milliliter, maybe 2. And so you're gonna push everything through. It might shoot a little bit. And this is the full flask. Maybe a tiny little bit lost there, that's fine. Remove the stopper carefully. And do a couple rounds to figure out how much volume we've got here. Don't want to lose any milliliters there. Fill it up to the first 100 milliliters. I want to do this as close as possible. So that's 100 milliliters. That's another 100 milliliters. And we're gonna end up with a total of 200 and, let's see the right measurement here, 77.9 milliliters. So we're gonna go over here and put this on our sheet before we forget, or rather, that's the kind of thing I would forget. We can put it for both of them. So 277.8 milliliters and 277.8 milliliters. So if you're using the same flask, this is possible. If you're using two different flasks because you want to speed things up, you could always do 2 separate entries. I prefer to do just one, and as long as you're working with just air in the environment around us, it's going to behave the same way, and you're not going to worry too much of you're not going to have much of a problem there. After this, you can find the final volume of the air after the intake V2. You're going to do that by subtracting this number from this number. So what do we get? We end up with 209.7 milliliters. Okay, so what we saw here was we saw basically the temperature went from 101.0 degrees Celsius to, we measured at 1.0 degrees Celsius. And in that time, we went from 277 milliliters to 209.7 milliliters. So we're gonna do that one again, and then we're gonna be calling it good. Oh, hey everybody, I didn't see you there. Hey, so here's the last little bit for the last lab. The biggest thing for this is making sure that, again, you check your temperatures regularly. I got my flask dried off with my Bunsen burner over there, and I put it back. It's a little smelly in here because the plastic didn't like it very much. And I have it boiling in this water bath. Very important for the water bath, it needs to be as hot as possible. You want that big temperature change to help you get a really clear result. So I have the thermometer. The thermometer says I'm at an entire steep, basically 101.5 degrees. Really jumping in there. So we have 101. Really should try to find that permanent marker, but I have not. Okay. These dry erase markers are going to come and find me in my sleep with the coronavirus. So at this point, we're going to take the flask as before and move it into the ice bath, taking care to keep the stopper in good contact with the flask. You want to make sure it's nice and tight so you don't have any leaks. And then also, until you actually have it underwater, you want to make sure that your finger's on top of the little point of the end of the pipette here. And that's to make sure that as the flask cools in the air, it doesn't already start taking on gas that we can't compensate because of the temperature change, or that we can't account for anyways. Must be the end of the day, I'm mixing up my words. All right, so here goes. You want to be swift, and I'm going to take the finger, put it into the ice bath, and once it's underneath, we're going to let it rip. Pretty immediately, you're going to see the water sort of pour in, and you're looking to make sure that all of the bubbles are not forming at the tip of your pipette or around the edges of your flask's stopper, mostly because all the water should only be going in there, not because it's giving up air to the atmosphere above, but because of the pressure that's being formed inside pulling that liquid in. That is very important, and it'll get really inaccurate readings if you have bubbles and you lose any kind of air pressure that way. So we're gonna sit here and take a second to observe whether or not we're at the same temperature as before. Sitting at about 3 degrees Celsius. Kind of mix it around here, see if I can't get a better reading. Obviously being careful not to bump the stopper. I'm moving back down to 2. This only needs to go on for about 3 or 4 minutes. The temperature change will be pretty drastic. Air is kind of an insulator, so you might want to give it, more time is usually a little bit better. But the more time you have it down there, the more chance you have of accidentally knocking some air into it that shouldn't, or water into it that shouldn't be there. Kind of a best of both worlds situation. So we're starting to settle the temperature at about 1.9 degrees Celsius. And I'm gonna hang that as our result. So let me just throw my finger on there. pull our buddy up and see what we got. Oh, I don't want to lose any of that water. There we go. Looks like we got quite a bit more water in there. We'll see what we got. Hopefully nothing too crazy. Maybe there was a leak or something, but who knows? Maybe it was just hotter. The amount of wild deviation in this experiment is pretty impressive, and so gives you more respect for the guys who tried to do this in the 1800s, for sure. All right. And now we will transfer into our flask. So, the big difference in temperature here caused us to withdraw about 94 point, about 94.3 degree or milliliters. So write that down. Okay, 94.3 milliliters. And when you look at the initial temperature, the nice thing about this part is you can always go back and double check, which I will. Never hurts. I'm gonna take a second though. And see if we're still hovering around, 1.8, 1.9. Oh yeah, we're even down to about 1 even actually, 1.0 degrees Celsius. Something like a little stirring can do. Now, when it comes to the calculations you're going to do for this particular piece of work, you want to make sure that you convert all of these to Kelvin, all these temperatures, because degrees Celsius are not going to work for the Charles's law calculation. And you're going to calculate the final volume by subtracting this volume from this volume, or this volume from this volume as before, to the way we got this volume. And that's going to be a pretty important way to sort of understand what we're actually seeing here. We're seeing a larger volume of gas turning into a smaller volume of gas, and allowing us to see how you would derive, in this case, through Charles's law, the temperature of absolute zero. This is going to be our limiting sig fig here, unfortunately, and so all of our answers are going to have to be in 2 sig figs, right? Other than that, the rest of it is just up to you and going through the calculations and the work that we did in class, or rather our Zoom meeting class, which is comparable but not the same, as you well know. And so we will also discuss this in other Zoom meetings, just to make sure that you understand the math here, because it's a little bit more complicated than the other concepts that we've covered. Of course it's the last lab, right? Of course it would be.